Today we're finishing up the notes for adding and subtracting rational expressions. And we left off on problem number 5. And we are subtracting rational expressions. A couple things to remember is that factoring can be your friend. And when we add and subtract fractions, we need to find a common denominator. Really, really important to find a common denominator. Also, watch out for that negative in there or the minus sign in between. Because we need to remember that a negative gets distributed over the entire numerator. And that's going to be an issue on this problem where it wasn't so much in problem number 4. So as we take a look at this one here, the only thing we can do to find the common denominator is we can multiply the two together. We don't have to factor anything, so that's the nice part on this one. We can leave it as x plus 2 and x minus 2. That's going to be our common denominator. But it really, I want to change colors there. I want to emphasize that we're subtracting. And if you recall from our earlier notes, what we asked ourselves is, what's in the denominator now that wasn't in the denominator before? Well, we've got an x plus 2 that was in there, and now what we have that's not in there is an x minus 2. So we're going to put that x minus 2 in there. We already had the x minus 5. And again, let me warn you, don't cancel that out. Because what we do to make a common denominator is we multiply by a fancy form of 1. And x minus 2 divided by x minus 2 is the fancy form of 1. Over here on the right-hand fraction, we have an x plus 4 in our numerator already, the top of the fraction. And now what we need to look at is what's in our denominator that wasn't in there before. Well, the x minus 2 was already in there, but now we have an x plus 2. So we're going to put this in. So we've got lots of foiling to do, and I am going to do one extra step in here with the subtraction, because this negative applies, the red negative applies to the entire numerator, or top of the fraction over here to the right. So I'm going to write one extra step. You decide whether you need to do that or not. It's going to be x minus 5 times x minus 2 minus x plus 4 times x plus 2, all divided by the common denominator of x plus 2 times x minus 2. Again, some people need to do that step, and some people don't need to do that step. But I need to be even more picky over here, because what's going to happen here is that that negative is going to apply after we FOIL that. And that's why I put in the brackets. Just something to remind ourselves that we have to distribute that negative over that entire FOILed or distributed process there. And so now we can get closer to the end, and what we need to do is we need to FOIL here or over here to the left. So we're going to get x squared minus 2x minus 5x plus 10. First, outer, inner, last, if you like the FOIL algorithm. Going to subtract. The value here, and we're gonna FOIL before we subtract. X squared plus 2x plus 4x plus 8. Again, first, outer, inner, last. And that's still over x plus 2 times x minus 2. Now distribute. You can combine like terms if you want to in that green bracket, but I'm just going to distribute because we're going to have to combine like terms in a couple minutes. So the x squared minus the 2x minus the 5x plus the 10, I know it's got like terms in there as well. But what I want to stress is that we need to distribute that negative there. So now we're going to get negative x squared, negative 2x, negative or minus 4x, negative 8 or minus 8, all over our common denominator of x plus 2 times x minus 2. Getting closer to finishing now. We've done the hard part, but it's distributing that negative, that red negative that causes an issue, if anything causes an issue. But we have x squared, and we have minus x squared, so those cancel out. We have negative 2x minus 5x minus 2x minus 4x, so negative 7, negative 13x. So it looks like negative 13, 2, 5, 2, and 4. Negative 13x. And finally, we've got a plus 10 and a minus 8, which is going to be plus 2. All divided by x plus 2 times x plus minus 2. Now the problem was long enough as it was, and we can't simplify anymore. We can't cancel anything out because we can't factor anymore, and we can only cancel when we factor. But always check when you finish. Can you simplify anymore? We've done the subtraction. Can we simplify anymore? The answer in this case is no. Here's our last example. And there's a couple ways to do this, but what we're really concentrating on today is we're concentrating on, can we add something together and can we subtract something? And in this particular problem, we're going to add the numerator, which is the top of the fraction. We're going to add the denominator, which is the bottom of the fraction. And then we're going to finish by dividing. So as we look at the top here, it's going to be 4. But instead of x squared minus 9, let's do the difference between two squares, and we get x minus 3 and x plus 3. And we're adding to that 2 divided by x minus 3. Well, once again, when we're finding common denominators, what we're looking at is, do we have anything exactly the same in the top and, sorry, wrong thing here. Do we have anything that's the same in both of the denominators? And in this case, what we see is we have an x minus 3 in both denominators. But we also have an x plus 3 in the left-hand fraction that we don't have in the right-hand fraction. So our common denominator is going to be x minus 3 times x plus 3. Well, we didn't put anything into the denominator in the left-hand fraction, so it's going to remain the same. But we did put something into the denominator of our right-hand fraction. We had an x minus 3, we put into it an x plus 3. So what we have here is we've got 4 plus 2x plus 6 all divided by x minus 3 times x plus 3. If we simplify this a little bit more, we get 10 plus 2x all divided by x minus 3 times x plus 3. Now, as I glance at this, what I see is that we can take out a GCF of 10 plus 2x. I think I'm going to save that for later, because what we've just done is we've only looked at the top of this fraction here. Now we have the other part, which is the 1 over x plus 3. And I think it's plus. We'll pull it back up here to c plus 1 over x minus 3. And once again, we have to find the common denominator, and the common denominator is determined, in this particular case, simply by multiplying the two together. The left-hand fraction has the x plus 3, the right-hand fraction has the x minus 3, and the only thing we can do is we can multiply those together. So what we put into the denominator over here on the left side is we put into it an x minus 3. What we put into our right-hand fraction is we put into it an x plus 3, and the nice part is they're both multiplied by 1, and any value multiplied by 1 is any value. So when we combine this here, we get x minus 3 plus x plus 3, all divided by x plus 3 times x minus 3. And when we simplify that, the like terms here of the negative 3 and the positive 3 cancel out, and we get 2x divided by x plus 3 times x minus 3. Well, if we go and we write this again, and I'm going to write it, but I'm going to then pull up my screen down. But remember what happened when we combined here. At the top of that fraction, we ended up with the 10 plus 2x divided by x minus 3 times x plus 3. That's what we came up with first, and then we came up with 2x divided by x plus 3 times x minus 3. Well, we're dividing this now. We added the top, we added the bottom, but to finish this problem, we need to divide. So let's take this again. I'm going to scroll farther down on the paper, on the page here, and we're going to write that again in old school form, which is the 10 plus 2x divided by the x minus 3 times the x plus 3. And we're going to divide by the 2x, and then we've got our x plus 3 times x minus 3. And when dividing, don't ask why, flip the second one and multiply. So I probably should have factored out the 10 plus 2x, so I'll do that right now. It's 2 times 5 plus x. We factored out a greatest common factor. We still have an x minus 3 times an x plus 3. Over here, we're going to multiply now, because when dividing, don't ask why, flip the second one and multiply. So we're flipping the second fraction and multiplying. And then we ask ourselves, do we have anything exactly the same on the top and on the bottom? Well, we have an x plus 3 on the top and the bottom, and not much else. But there is a teeny bit more that maybe you see and maybe you don't. But what we have left so far is we have 2 times 5 plus x times x minus 3. Oh, shoot. And I'm going to erase that because look what else. And you're probably out there saying that. Oh, we have x minus 3 and an x minus 3. So now a little bit better. We've got 2 times 5 plus x up there. And in our denominator, we've got a 2x. Remember, we can look at that monomial, those single values there. We've got a 2 that's exactly the same on the top and the bottom. And those values cancel out, and we're left with now 5 plus x. 5 plus x divided by x. So connected to your paper are the practice problems. And talk to your teacher about the second one because I changed it a little bit and there's a typo in it. If you want to get the same answer as that's on the back. But go ahead now and practice what you've just learned over these last couple days in preparation for a quiz later on in this unit.